Hi, welcome to Steve's Wood Cave. This video is about through dovetails on the WoodRat, but in detail. The idea here is to look at it in more depth for those of you that want more information about how to do this. I hope to make a shorter video later on, which will be just like a memory jogger, and that will be more useful and shorter. It's 30 odd minutes long because there's a lot of details and a lot of things that you need to get right. Once you get used to this technique, a lot of it will fall away and will become second nature. So hopefully this will help. I've got two cherry boards that I'm going to join together with through dovetails. They're 195 by 95 by 19 millimeters, just to give you some dimensions for reference. But for this technique we need two cutters. We need a dovetail cutter or bit, and we need a straight bit. My dovetail bit is a WoodRat DC6 cutter, and it has a diameter of 15 millimeters, and this is a spiral cutter which has a diameter of 8 millimeters. So those are the two bits I'm going to use. I will assume that you already know how to make a cutter profile template and transfer the cutter profile onto the front face of your WoodRat. If you don't, I will put a link somewhere around here to another video that I've made. This is a cutter profile template made of the dovetail bit. So don't throw this away once you've done that, once you've made this, as you will need it later on when we come to cutting the pins. So let's see how we do this. So now my pieces of cherry I've squared off the ends. I'm going to only make one dovetail corner joint in with these two pieces of wood, but I'll show you what you can do if you want to put dovetails at both ends of the board with the flip and turn technique. But you need the measuring jig, which I think I've talked about in an earlier video. I'll put a link up for that. So we've got a centre line, again it's in the previous video, it shows you how to get the centre of your router bit. So this needs to be moved until it's just in line. The edge of this is just in line with that router mark. You can see that half of the pencil dovetail cutter profile is now covered up. So I'm going to put this in here, and this is going to remove half the diameter of the dovetail bit from each shoulder. So that means that the base or the shoulder widest point is going to be 7.5 millimeters. Fingers crossed anyway. So what we're going to do is we're going to cut the first shoulder, then we're going to turn it around 180 degrees, keeping it the same way up, same end grain up. Cut the second shoulder, then we're going to flip it over, head to tail, and then we're going to cut the third one, and then we're going to rotate it 180 degrees again and cut the fourth one. There you go, we've got 1, 2, 3 and 4 by doing the cut the first one, turn the board around, cut the second one, flip it over, actually it's flipped over that way, cut the third one, turn it around, cut the fourth one. That's it. They are now symmetrical, so everything should be absolutely fine. Alright, let's move on to the next stage. So now with the measuring jig in place, so I've marked up a line at 30 millimeters from this edge, as you can see here, and we're going to basically move the measuring jig along to meet the centre line. So now with the measuring jig set to the centre line at 30 millimeters from the edge of the measuring jig, I'm now going to cut the first one. there you go. That's all 4 cut. Now what we're going to do is we're going to widen that slightly so that we end up with 3 tails the same base spacing. At the moment this middle one is much wider than the outer 2. So we cut the initial tails at 30mm, measured with the centre line here. I've added 2.5mm, so that's from this edge to there is 32.5mm. So if I now move the measuring jig across to there, in line with the centre line, we shall now be able to remove 2.5mm from that centre tail. And that should make it roughly the same size as the outer tails. Right, so that's it, everything is symmetrical, and we have about 14.9mm at the base of this. The base here I'm measuring 14.8, 14.9, but to the naked eye it will look pretty much the same, and everything is symmetrical, so that's brilliant. Doesn't matter which way around you put this board, it will fit the corresponding pin. The reason I use the DC6 dovetail bit is to make this very clear to you what's happening. If I use a smaller dovetail bit, then it won't be quite so evident what's going on when we come to cut the pins, and we're going to come on to that interesting part now. Okay, it's basically 2 steps to cutting the pins. I'm going to show you on the board here, and then I'll show you on the machine in a minute. But basically we have on the right here a plan view of the body of the rat, which is in this hashed background, and then the base plate is shown projecting out in front of the body. So as if we're looking down on top of the WoodRat. In the middle here at an angle is the router plate, and on the corners here we've removed the of course what you have to do when you're making the pins is we want to make an angled cut, so we need to remove the straight guide rails. So the guide rails are replaced by these cam spirals or spirals, and they basically allow you to set the angle of the router plate movement. The router plate is guided by the centre plate, and the centre plate has what's called a button, this orange part here, which has a hex key in it, and this has a T-shaped locking part on the back which actually locks this. The whole centre plate is then locked to the base plate, but it allows the router plate to move backwards and forwards through it, through the T section on the actual centre plate. So what this does is it sets this red pivot point here and allows the router plate to move backwards and forwards, as you can see with the red arrows here, in this direction, and then we can rotate it and move it backwards and forwards against this right hand spiral. So the router plate, when it's being used, is always kept at all times against the spiral for the cut that you're doing. So, and then eventually you should end up with a test pin that looks like this. We need to calculate the button setting, so we need to know where that pivot point needs to be. So where do we set that to? In order to set that position, we need to calculate the button setting using a formula. The second thing we need to do is set the spiral cams at the right angle, and you'll notice on your base plate that there is a circular scale. But this is what we're aiming for, a test pin first. Once we've got that to fit into the cutter profile template that we made initially, then we can basically cut the real thing. Okay, so on this side of the board we've got the formula for the button setting, which is the dovetail diameter plus the straight bit diameter, all divided by 2 and then multiplied by the slope value. So in my case I've got a 15mm diameter dovetail bit, 8mm straight bit, so 15 plus 8 is 23, divided by 2 is 11.5, and we multiply that by a slope value of 6 because I'm using a WoodRat cutter which has a is a DC6 and it has a slope value of 6. All the WoodRat cutters have a single digit slope value, so that turns out to be 69. However, if you've got tungsten carbide bits you're using, you'll notice that they will come with degrees when you buy it. So this table basically gives you an equivalent slope value for 6 to 14 degrees in steps of 1 degree. So your slope value number would be put in there instead of the 6. These numbers are all derived basically from a bit of simple trigonometry, school trigonometry. I'm sure you're all familiar with tan of the opposite over the adjacent. So for theta here, this angle here, we take the opposite, which is 1, divide it by 6, and we take the inverse tan, and then we get 9.46 degrees. So this is for my 1 in 6 slope. The slope value 6 is exactly the same as 1 in 6 ratio. So you know that a ratio can be derived from a triangle like this. So that's how you would work it out. But to save you all that working out and giving you a headache, you've got all these values already worked out for you here for a given number of degrees for this angle. So that's the nasty maths out of the way. Let's go and have a look at it on the machine. So now we've got the button setting, we can take the centre plate, pop it into the router. Obviously I've taken the aluminium guide rails off. Spirals are in place but they need setting. The centre plate goes in there and you pull it back until it goes into like you can feel underneath there's like a T-slot which this part slots into. Should be able to feel it. Right, you'll feel it engage. Now I can't pull it off. With this now, in my case, my button setting was 69. Now it depends on where your base plate is fitted to the body of the rat. There's 3 positions: P1, P2, P3. For my router bit sizes, I need to use the middle datum line. So on this centre plate, there are 3 datum lines. There's one here at the top, one in the middle, and one at the bottom. So the one in the middle is the P2 one, so I'm connected to the body of the rat at P2, so I need to use that datum line just there in the middle. Yeah, if you were connecting your base plate to the body at position P1, you would need to use the datum line in line with the button. And if you're using the P3, then you'd use the one at the bottom here near this projecting part. So these different P positions, both for the base plate connected to the body and also on the centre plate. The P1 position, which is one near the button on the centre plate and the one at the front on the base plate, that's used when you've got a situation where you've got small router bits. And the P3 one is when you've got much larger router bits, sort of up to, I don't know, 1 inch in diameter. But you'll know immediately whether you're using the correct datum line or whether you're using the correct position for the base plate, depending on the material that you're machining and the router bits that you're using, because this centre plate won't link up with the slot in the underside of the base plate. So you should know pretty soon which of these datum lines you should be using to get your button setting set on the router plate here. And if you end up having to measure from 8 to 15, if you've got a button setting which is greater than 8 and up to 15, then you have to put the orange stopper in the front here and bring the router plate to the front stopper. You can see it's written on this scale here. And so yeah, if you're using this left hand scale, as it says at the top, it says register with the router plate against the backstop. But for most average furniture making, for drawers and stuff like that, you're probably going to be using this middle one and have the base plate connected at the P2 setting. So anyway, I'm using the middle datum line, so I set that to 69, which is on this scale, but the router plate has to be up against an orange plastic part which is in a hole at the back of this base plate, right at the back. Push the router back until it hits it, and then set this datum line to 69. And then you tighten up the hex bolt in the button. Okay, make sure it hasn't moved from where it needs to be. So this centre plate is locked to the base plate now, but the router plate can move using this groove here, and basically guides it left and right at an angle. So this is how we're going to cut the test pin. One movement this way and then another movement this way, ensuring that the router plate is pushed against the spiral cam. For this right hand one, push it to the right. For the left hand one, push it to the left hand cam. Has to be in contact at all times during the cut. So that's the button setting now set, that's done. So now what you do is take a sliding bevel, as you'd use in your hand tool work, and we set this and try and get it as accurately set to the slope that we've marked on the cutter profile here. So this is the cutter profile template that we cut earlier, and we put the pencil in the marker position and marked it onto the front face of the rat body. Now I said earlier that we need to keep it, and we need to keep it because we're going to make a test pin like this. This is one I made earlier. The important thing here is the sides, the angle that we're trying to achieve by setting the spirals on the base plate. So I'm going to use this unused end. It's not square, it doesn't matter the length of the pin to insert into that profile template, doesn't really matter too much. We're only concerned with the angle of the cut. So I'm not even going to square it off or anything, it's as it is. And depth of cut is fine. Earlier we set this sliding bevel to the angle of the penciled dovetail at the marker position, and we have this set now. So in order to set the spirals, we need to put the sliding bevel on here along the front edge of the base, bring the router plate forward. We're going to set the right hand spiral. This has a cam on it which moves it and changes the angle of cut. Once we've set one of these, we'll then set the other one to the same number. So we use this as our reference. We want to rotate the router plate until it's aligned on this left edge here. Rotate the spiral around, lock it off. Okay, so this number's come to about 85 on this right hand spiral, so if I set this one to 85 on the left as well. Okay, that's both of them set to 85 now. So let's see what we cut. Okay, we've got an 8mm spiral down cut straight bit in there, so let's go. Okay, so that's the pin now come out. What we need to do is just chop these ears off. It's the middle bit that we want, and we'll measure it across the width and see if it fits the cutter profile template. Okay, so I've now chopped those off on the bandsaw. Let's see what measurement we get across this widest part of the pin here, this top part. So about 15.6. So the diameter of the dovetail bit is 15mm, so we're 0.6 of a millimetre too wide at the widest point on this pin. So that means we need to change these spirals by 0.3 on each side to make 0.6 total. So we can't take 0.6 from both because then that would take 1.2mm away. So we're just going to set one to 0.3 down. So this number here is 85 and this is 85, so they need to come down to 82 each, because each of these tiny divisions here is 0.1 of a millimetre, so we need to take 0.3, so we move down 3 small divisions, so that should take us down to 82 on each side, and then we'll check again and see if it's fitting the I mean, I know for a fact this won't fit, it's just, yeah, it's just too big, it won't go in. So we'll put that back in. Remember to put it in the right way. The narrower part is at the front facing you. Okay, so knock this down to where we said, and this one too, and we'll try again. Ouch. Okay, there you go, it fits. I took it down slightly less than 3 actually. I took it down 5 marks because sometimes it's good just to have a slightly looser fit. In fact, that's still pretty tough. So, as you can see, it's a good fit. So now we've set the spirals, we can now cut the real pins on the real boards. Incidentally, if your first initial pin is too narrow, then you need to turn these spirals up. So if you were on 85, then you would need to go towards 90 on each of them, because that would then widen the pin. So you only lower the number when you want to narrow the pin. So we had to make that pin narrower because it wasn't fitting, so we knocked the numbers down. Doing the test pin is also something which may frustrate you initially. It may take you more than 2 goes, it may take you 3, 4, 5 goes, I don't know. But once you've got used to doing this, you've done it a few times, it really does become second nature. So don't panic if you don't succeed at first, but once you've sussed it, you'll realise just how straightforward it all is. The other thing to note is that once you've got your cam spiral settings on these circular scales, so in this case we've got 80 and 80, so 80 is all you need to remember, and we know that our button is set at 69 in the P2 position, then that's all you need to remember for the 2 cutters that I'm using. And if I use them again, I know immediately it's got to be set to 69 on the P2 and 80 on the spirals, and it will cut exactly the same again. So it's only a one-off thing for the pair of cutters that you select, but if you ever regrind any of the cutters, or you swap one of them out for another cutter, a different size cutter, or even an equivalent cutter, but you think it's the same size and it's not quite the same size, then you might struggle to get what you need. So remember the numbers, write them down somewhere safe, and you can then refer back to them later. So this isn't something you have to do absolutely every time. You just have to keep a good log of which bits you've used and what settings you ended up with, and you should be able to do it pretty quickly then. Should also measure that coming out of there after the second cut. Yeah, it's just under 15, so ranging from 14.9 to about 14.7. So although that base is 15, it does need to be slightly less, and it slides in quite neatly. So now we've set the spirals, we've set the depth of cut, we get our other piece of cherry, put that in the cutter position. That's what we're going to cut the pins in, and then the board we made earlier, the tails, goes in this place, goes in the marker position. So it's important to show you that the top of the tailboard should be flush with the WoodRat. The pencil line, when we're cutting through dovetails, must be showing. So we've lined up this shoulder because obviously we want to remove, well, we don't want to remove, we want to cut the pin that is going to go into there. So we cut the right hand side, we align the right hand side of this cutter profile template and basically line it up with that, with the pencil showing. So we move this backwards and forwards, so we leave just the pencil showing. If you've got a gap between the pencil and the side edge of this tail, then you've set it in the wrong place. So now with the router plate touching the left hand spiral, we can cut the pin that will go in that side. You have to move the thing along to here, to the next one. Again, showing the left hand side of the cutter profile template, the line just showing. And we make the next cut. So this time we've got the router plate running against the right hand spiral. I've moved the cherry template so the right hand pencil line is just showing on this inner face of this middle tail. Now the router plate is against the left hand spiral. I'm going to make another cut. So now I've moved the cherry template so that the right hand face of this middle tail is just to the left of this left hand pencil line. Now I'm going to make another cut, and then I'll do the same. I'll move the template along and this left hand face of this right hand tail so that the right hand pencil line on the cutter profile template is just showing. And again, the left hand pencil line, I'll move this template along to cut the end pin. It will just be showing off the face of this right hand tail. So I'll do the whole lot in one go now so that you can see what the end result is in a second. What you'll notice is that you've got these extra bits in the middle. The outer pins are fine, you want to keep those, and you want to keep the big pins in the middle. But these need to be removed, they're waste. And you always know this is waste. This was the face of the piece in the cutter position that was facing me when I made the cuts. You always know that the waste bits have a point which points towards the back of the rat. So I'm just going to remove those. So I've just removed the waste. All gone. Should be left with just the pins that we want. Now remember, the test pin was quite tight, so I'm expecting this not to push in extremely easily. It's going to take a bit of a tap. It does go. And there you go. It looks like I've set the depth too deep. We've got protruding pins. I've obviously done something slightly wrong there, but other than that, it doesn't get much better really. I think I may have forgotten to set the depth of the thickness of the wood, so we've ended up with pins that are slightly deeper, slightly longer. That's why this is protruding. So yeah, always remember to check your depth setting before you cut the pins. But anyway, you see the process. It's pretty good. This is showing the joint finished and lightly hand planed. There's still a little bit of protrusion there which can be cleaned up. The same here. But you can see, you should be able to see that the fit is very, very tight. There you go. So it's a very good method. It's pretty much symmetrical, virtually flush, nothing a hand plane can't sort out. There, and very, very tight fit, which is what you're after. Obviously there's a bit of faffing about, messing about when you're creating the test pin, but once you've done the test pin, you're pretty much sailing for everything then, and you can knock these out very quickly. I would just keep it with the board in that orientation, cut the tails, flip and twist, and then you get everything symmetrical. And you can just put the next board in and do the same again. So it's very, very quick to do the tail boards. Pins take a little bit longer, but not that much longer. And once you've moved the tail template, what you want to do is for that one position is put your joining boards in that you want your pins in, one after the other. Cut the same joint, so do one, take it out, take the board out, put the next board in, cut the joint, and again you can rotate if you want as well. That's how you do 3 dovetails on the WoodRat. There may be other ways, but that's the way that I was taught to do them, so that's what I recommend. The other thing is that although this is a very ordinary layout, we can of course be completely artistic and lay out any width of pins or tails we see fit. I mean, you're guided by that, so you know where the bit is going to cut as soon as you put your template in there, so you can make up any number of different designs. So that's good, much more freedom. Alright, well thank you very much. If you have enjoyed this, please like it below. add your comments. I'd be interested to hear from you. If you've got a rat and you're having problems with it, let me know. I'll try and help. That's it. Thanks very much. Bye. Thanks for watching, and if you like what you see here and you're new to this channel, please subscribe for more updates as they come available. Otherwise you can follow me on Instagram, Twitter or Pinterest, so that would be greatly appreciated. Thank you very much. See you again.